Hello everyone, welcome back to our channel. Today we are going to solve yet another very interesting question, min XOR value. We're going to start with understanding the question, then we'll go to the brute force solution, then we'll try to optimize it, get to the optimized solution, and then we'll write the final pseudocode, and finally we'll move on to the coding part. So make sure you watch the whole video, do not miss out. By the end of the video, I'm very sure you'll be able to solve this question yourself. So let's get started. Min XOR value, given an integer array A of n integers, find the pair of integers in the array which have minimum XOR value, report the minimum XOR value. That's it. So you just have to find what XOR value is minimum out of all the pairs that are there. You calculate the XOR, you send the minimum value. That's the most basic thing that we can do. Let's have a look at it. So the name of the question is min XOR value. Okay. Now we are given an array of integers, right? Let's take an example 0 to 57, 0 to 57. This doesn't have to be sorted. By chance, this is sorted. Let us unsort this, okay? So that we don't get an impression that our arrays are sorted. Now, what you have to do is, out of all the possible pairs that are there, you have to calculate the XOR and you have to find the minimum XOR value out of all of those values. That's it. So basically, you have to calculate 2 XOR 0, 7 XOR 0, 5 XOR 0, then 7 XOR 2, 5 XOR 2, then 5 XOR 7. That's it. Out of all the values that are the outputs of these operations, you have to find the minimum one and return that as the answer. So the brute force solution is quite simple. Take all the possible pairs, calculate the XOR value, get the minimum one, and return that as the answer. I'll just solve it using the brute force method. Look at this very carefully. Okay, I'll write the pseudocode over here. First of all, you create a variable. Let's call it answer. You started with int max. Then you iterate over the array using 2 for loops so that you get every possible pair that is there. So you loop from 0 to n minus 1 using an iterator I. Then inside this loop, you have another loop. So you loop from I plus 1 to n minus 1 using an iterator j. Now we have all the possible pairings that are there in the particular array. What we'll do is we'll make answer equal to minimum of answer and the XOR of the two numbers, a of I, XOR a of j. By the time this loop ends, we will have the minimum possible XOR that exists inside our array. So when we come out of this loop, we can simply return answer and be done with it. What is the problem? This is the brute force approach. Why? Because we have a loop inside another loop. Because the loop is inside the other loop, the time complexities are going to get multiplied with each other. So O of n into n, O of n square is the time complexity of this particular approach. Space complexity, we are not using any extra space, O of 1. So we need to reduce the time complexity. Let us look at how we can do that. Before we move on to the optimal solution, there is one theory that I want to discuss with you guys. If there are three numbers, A, B, and C, and the relation between them is A is less than B, B is less than C, what I'm trying to propose to you is A's or C will always be greater than A's or B or B's or C. What I mean by that mathematically, if I write it properly, is A's or C is always greater than minimum of A's or B, comma B's or C. Now A, B, and C all are binary numbers. So let's take some binary number, for example, and A and B and C all are same in the first 4 digits. This is where the difference arises. So this is a 0 over here. For C to be greater than A, it has to be a 1. Whatever comes in front of it is of no consequence. In B, this can either be a 0 or a 1. And then there are some digits in front of it. So we will take both the cases. The 0 case is when this bit is 0. So let's take that example. A is 10110101. B is 10110, and there are 4 digits in front of it. I hope you understood why I've taken that this can either be a 0 or 1, because this has to lie between A and C. Okay? And then we come up with C, 10111, and anything can be in front of it. Now in this case, let's do A XOR C. So starting bit is going to be 0, because for same bits the XOR is 0. Then 0 0 is 0, 1 1 brings 0, and 1 1 again brings 0. The next is 0 and 1. When you XOR these two numbers, you're going to get a 1 as the output. And then some more digits. Let's try to do A XOR B. Okay, this is the 0 case. So 0 0 0, and because both are 0 over here, it's another 0. And then 4 digits in front of it. If you do a B XOR C, you will get 0 0 0 0, and because this is a 0 1, a 1 comes over here, then 4 other digits. Now you can see the minimum of these three is always A XOR B. So when it is a 0, A XOR B is minimum. I've just proved it. Whatever values come after this, it doesn't matter. This is going to be the minimum possible value out of the three values, right? Similarly, let's take when 1 comes in that particular place, right? In this position, when 1 comes, what happens? So look at it very carefully. A is 1 0 1 1 0 1 0 0 1. B becomes 1 0 1 1 1, and then 4 digits. And C becomes 1 0 1 1 1, and then 4 digits. Let's calculate A XOR C. So this is going to be 0 0 0 0, because the first four digits are same. Then 0 and 1, this becomes a 1, and then there are 4 digits. A XOR B. So first four digits are same, so 0 0 0 0. 0 and 1, the output is going to be 1, and then 4 digits are going to be there. Let's calculate B XOR C in this case. First four digits are same, so 0 0 0 0. 1 and 1, this digit is also same, so a 0 is going to come here, and then there are 4 digits in front of it. So in this case, as you can see, B XOR C is going to be the minimum value. So in no case, either it is a 0 or a 1, A XOR C is never the minimum value. It's either A XOR B or B XOR C, and hence proved. I just proved this theorem to you. So what I wanted to show you by this experiment is, when we sort the array, if we sort the array, the numbers that are closest to each other will come together, and only those number can result in the minimum XOR value. The numbers that are farther away will never have a minimum XOR value. We'll use this logic to solve this question. Let's see how we are going to do that. So first of all, we'll take one more example from the question. So all the arrays are, the examples are sorted, but it's not actually the case for all the test cases. Let's create our own test case. So if 1, 10, 6, 4, 5, okay? So first of all, we are going to sort the array 1, 4, 5, 6, 10. And then we are going to iterate the array and only calculate XOR for the consecutive numbers, because one of them is going to be the minimum, as we just saw the proof for. Okay. So for sorting, the time complexity becomes O of n log n. And then we have to traverse the array once simply to calculate the XOR for the consecutive numbers. That's all. So that happens in O of n. Overall, the time complexity would become O of n log n, because this is the greater of the two. And that's it. We have reduced the time complexity for O from O of n square to O of n log n. Let me write a small pseudocode for this so that it's crystal clear to all of you what we have done so far. And by the way, whatever doubts you get, guys, whatever doubts you get, please feel free to put them in the comments, and I'll be more than happy to clarify any doubts that you guys have. Okay? So what we are doing is we are sorting the array. So sort the array is the first step. Then you take a variable answer, initialize it to int max, and then you simply run a for loop. Okay, so you loop from 0 to n minus 2. You don't go to the last digit. Okay, why? Because we are going to consider the XOR for a of I and a of I plus 1. If you go to the last index, it will become out of bounds. Using an iterator I, and every time you just have to calculate the value of answer, that is minimum of answer, comma, a of I XOR a of I plus 1, and this is it. When you come out of this loop, you already have the answer in the answer variable. You return that as the final answer. And we are done, guys. This is how the pseudocode is going to work. Now we are going to convert this to a proper C++ code. But so far, whatever doubts you get, let me repeat that. Whatever doubts you're getting, please put them in the comments below. I'll be more than happy to answer those. So the code part is quite simple here. We first of all have to sort the array. Now we just have to run a for loop. Before that, we declare our answer variable to store the final answer. Then we run a for loop. It starts from 0 less than a dot size minus 1 I plus plus. And every time we update the value of answer as minimum of answer, comma, a of I XOR a of I plus 1. And that's pretty much it. We can simply return the answer variable when we come out of the loop, similar to what we have done in the pseudocode. Let me try to submit this. And here you can see we are able to pass all the test cases. All right, guys, thank you so much for your time. And I hope this question is now clear to you and you can solve it yourself. Whatever question you want me to cover next, please put that in the comments as well. And I'll see you in the next video. Have a wonderful day.